For 2D.
All right, guys, let's go ahead and get started. Let's go over exam 2. Which you guys had before the break. You guys may have forgotten about it already, right? All right. So the first question here was about the results of the Rutherford gold foil experiment. And he did find that most of the particles passed through. However, the deflection of the particles is why we currently have the modern model of the atom. So the correct answer there was D. All right, the next one here, an atom containing 7 protons, 8 neutrons, 7 electrons, is charge neutral. And I also went ahead and put the mass number here. This is actually nitrogen 15 that's mentioned here. You just add these numbers to there. But the main thing for this problem is noticing that the protons and electrons are equal. So it's charge neutral. All right, next one's here. Which one of the following is a main group element? And I went ahead and labeled which one's which. So A was an inner transition, B and C were transition, and then cesium, choice D, is a main group element. All right, and number 4, nonmetals are located where? They are on the right side of the table. Recall that the majority of the periodic table are metals. And just the ones to the right of that zigzag line on the periodic table are your nonmetals. All right, group 7A, those are your halogens. And then the last one for this page, Mg is part of which family? It's in group 2, which makes it an alkaline earth metal. Remember, the name for that comes from if you have these metals in water, the water tends to become alkaline. And we'll talk a little bit about alkalinity today. All right, and number 7, when an atom loses an electron, the particle is called, so in this case, if you're going to lose an electron, you're going to have more positive than negative, which gives you a positive charge, which makes it a cation. And the way you can remember that is kind of silly how I remember it, is that when cats fall out of trees, they land on their feet right, which is positive. So that's how I remembered it. So cation, anion. All right, next here. Oh, I wanted to go back to this real quick and mention something that sometimes people remember the charges by the cathode and anode of a battery. But the thing is that you guys will learn in Chemistry 122 that the cathode and anode don't always have the same sign. So that's not a reliable way to remember that. All right, number 8, how many protons and electrons are present in oxygen? So you look at the periodic table, and by the definition of what oxygen is, you have 8, because it's element 8. And then having a negative 2 charge gives it 2 more electrons. So choice C was the correct answer. All right, next one here, very similar question. Identify sulfur here being negative 2, element 16. And if it's negative 2, you have 2 more negative charges, 2 more electrons. So the correct answer there was C. All right, number 10, an atom of carbon-14 isotope would contain. And remember that the mass number is protons plus neutrons, so you can use that difference here to calculate the neutrons. By definition, carbon has 6 protons because it's carbon, and then the difference is 8, and then if it's charge neutral, it should be 6 electrons. All right, next one here, which of the following statements about chemical formulas is false? And the correct answer here is B. These don't represent the relative mass. They're basically the relative ratio of the atoms to each other. So they're not the relative mass. All right, and the next one here, how many atoms total are there? And then I went ahead and just added them up. We have 2 aluminums, 3 carbons. Don't forget you have to distribute the 3 to everything in the parentheses, giving us 3 carbons and 9 oxygens. And adding that all together, it's 14. All right, and if at any time you guys have questions, feel free to stop me. All right, next one here, which of the following does not exist as a diatomic? So I went ahead and wrote all the diatomics up here. You should remember that. And it works out where it's neon is the only one that's not in that list there. Another giveaway for that is that neon is a noble gas, so those typically don't react, they typically don't form bonds to other things. All right, next one here, which What is the formula for an ionic compound of barium and nitrogen? Both of these elements have common charges, which I wrote here, which we can get for which group number they're in. And then doing the cross method, I get Ba3N2. That does not reduce any further. We're good. All right, choice A. Next one here, what is the correct name of COS? You may notice that cobalt is a transition metal, so we have to include that in the name in a Roman numeral. And you could use the charge on the sulfur because that's one of the ones that always has the same kind of charge. Use that to figure out the charge on the metal here. And it works out to be cobalt 2 sulfide. All right, next one here, which is the incorrect name. It was choice A. It has, what should we have here for the name? Should be nitrate. All right, next one here, which is the correct formula for potassium dichromate. And it's just, these are the ions here. Putting it together, we get choice D. All right, actually I have a little bit of an error right here. The name nitrite actually is correct, but what is incorrect about this one? Going back to this one real quick. Does anybody see what the problem is? Anybody? The 3 here is wrong, right? What should it be? It should be a 2. Yep, so this comment here is incorrect, but that one is still the correct answer because that should have been a 2 because magnesium has a 2+ and nitrite has a -1. All right, moving along here, we just talked about that one. On this one here, which of the following pairs do not match? And it turns out they're all correct. All right. This next one here was naming a molecular compound, meaning it's not ionic, it's all nonmetals. So hepta is for 7, octa is for 8, so P7F8 is the correct answer there. Which of the following is the formula mass for sulfurous acid? So here we have a cumulative question. So the first thing you needed to do was get the formula. This is from sulfite. Remember, we name acids based off of their anion, and sulfite is an SO3 2-, so I added the 2 H pluses there, got a formula, calculated everything here, got 82.079, that is close to choice A. Keep in mind that your sig fig may be a little bit different depending on how many sig figs your table has. In a problem like this, choose the one that's closest to your answer here. All right, so question number 21 here. A compound has a formula mass of 61.98. And it says here it's comprised of sodium and oxygen. And honestly, you don't actually need the formula mass here. So this is one of those questions where you're given information you don't actually need. You could have used that to get the answer, though. So what I went ahead and did is, okay, it's sodium and oxygen. It is a binary salt. So even though it's Na2O, we don't put the disodium on there because it's an ionic compound. Remember, we don't put how many there are for ionic compounds. So even just having sodium and oxygen there as your wording there, you could have came up with choice C as your correct answer. All right, next one here, how many moles of copper are in this many atoms of copper? So here we just go ahead and divide by Avogadro's number because we have that many per mole. And I get 24.6, which makes what B the correct answer. All right, next one here. We have 10 grams of each. So recall that the way we calculate moles is typically by dividing by the molecular or atomic weight. And it works out where the smallest molecular weight or atomic weight will give you the largest number of moles because they have the exact same mass for each. All right, next one here. This one, some might see it as a trick question there, but you had to recognize that bromine is a diatomic element. So it's Br2. And you need to divide by 159.8, not the 79.9. And I do believe the dividing by 79.9 is one of the incorrect answers there. So be careful of that. When you're doing problems in this class and other science classes in general, the author of these questions typically knows common student mistakes, and they'll make them choices. So don't think just because your answer matches the one that you automatically got the right answer. It does not always work out that way. Yeah, I've seen that a lot in chemistry and physics. People do that. All right, next one here, calculate the molar mass of calcium nitrate. Similar to the previous one, you had to get the name first, or the formula first from the name. And there, I added up all the atoms and then their masses and came up with 164.086, and that's close to choice D. All right, next one here, 1 mole of ammonium biphosphate contains how many moles of oxygen atoms? So hydrogen atoms. So here you just had to add up how many hydrogen atoms you have. There were 8 in the ammonium ion, and then you get 1 from the biphosphate ion. So adding that all together, it's 9. All right, next one here, we have a 500-gram sample of iron, has this much iron in it. So this is probably like an iron ore of some kind, or an iron salt. And to get the percentage, you just take the component divided by the whole and times that by 100%. All right, next one here, oxalic acid. You're given the formula. You just had to do the same thing we did before, add up all the weights together. And then here, what is the percentage of carbon? So I took the carbon component here, the 2 carbons, divided by the total, and then came up with 26.681%, which matches choice C. All right, next one here, an iron chloride compound contains this many grams of iron, this many grams of chlorine. So in some of these problems you're given percentages, but these ones you're given the grams straight up right here. So I went ahead and converted them each to moles, and doing that you may have noticed they're already whole numbers. So you're pretty much done at that point. It's iron 3 chloride. All right, and then the last question here, this one you were given percentages. So we assume there's a 100-gram sample, allowing us to use the percentages as if they were grams, and then convert each of those to moles. And then you may notice here that they're the same molar quantity, so it's just MgO. Another thing also about number 30 there is you may notice that magnesium and oxygen are elements that have the same charges all the time. You actually could have got that just by the name that you learned in the previous chapter and not even did the calculation, and you would have got the correct answer here. So we had to do the calculation with the previous one because we don't know if it's iron 2 or iron 3. We don't have that issue with this compound. All right, are there any questions at all about the multiple choice? So I do want to point out that I'm using the par score machine. It does not actually show you incorrect marks on there, but it gives me a report. So on your scan, I wrote a number, and that's how many the report was telling me you got correct. So if you're wondering about which ones you missed, I recommend it's comparing it to this here, and then looking at the number you got. All right, the next one here, short answers. You have to do the following calculations. So, and whenever I do these short answer questions, I try to choose cumulative questions because they're worth a little bit more points than the multiple choice are. All right, so here we have how many oxygen atoms are in 3.5 grams of magnesium phosphate. So here we had to first get the formula from the name, and then from there you can calculate a molecular weight. Did not show my work here, but it works out to be 262.86 for the molecular weight. And then here I went from grams to moles. And then next I went to moles of oxygen. I got that number 8 from the formula. There are 8 oxygen atoms. And then lastly, to get it in terms of atoms, I multiplied by Avogadro's number. All right. Next one here, how many moles of sulfur are in 3.5 grams of ammonium sulfate? Just like part A, we had to get a formula first, then a molecular weight. And then the calculation here is identical, except for we don't have to go to the number of atoms. It's asking for number of moles of sulfur. So divide by the molecular weight, and then convert to moles. It works out to be 1 to 1. And then here we go. All right, the next one here is I gave you the percent composition of nicotine, and you had to get a formula from this. And then notice here I say molecular formula. But it works out here when you go through the work, converting them all to moles, dividing through by the smallest. It ends up working out where this empirical matches your molecular. I confirmed that by calculating the weight of that, and it matches to be pretty close to 303. All right, and the last question here, I asked you to determine the percent composition of vanillin, which is the main component from vanilla bean extract. The formula is C8H8O3. So here I went ahead and calculated a molecular weight. And then for each of them, I took the component divided by the whole all the way down here and then get that percentage there. All right, are there any questions, comments, or concerns at all about exam 2? All right, so if you are uncomfortable with mole calculations, definitely make sure that you spend the time to get this under control, because you're going to have to be good at mole calculations in the coming chapter. So calculating things like molecular weight, number of moles, things like that are very important in the coming chapters. So if you don't understand that, please make sure you get it under control and understand it sooner than later. All right.